limit of polynomial functions. So let us make a brief detour to polynomial functions. A polynomial function is a function that takes this form. F of x is equal to a sub n times x sub n plus a sub n minus 1 times x raised to n minus 1 plus so on and so forth until you get to the constant term. So this is the constant term, and n is a positive integer. That is how we define a polynomial function. Now, the degree of a polynomial function is the highest integer exponent of any term. So this one, for example, is a degree 2 polynomial function. This one is a degree 4 polynomial function. This one is not a polynomial function. Now we have this thing called the leading term. And the leading term is the term that carries the degree of your polynomial function. So here, your leading term is x squared. The leading term here is 5 times x to the 4th. Let us visit our understanding of indeterminate forms. So when we are evaluating the limit of a function as x approaches a, or as x approaches infinity, or as x approaches negative infinity, when the initial results gives any of these forms, then what we have here is an indeterminate form. We are working with functions whose limit is indeterminate. It cannot be determined yet. You cannot yet tell the limit. You cannot yet be certain about the limit. In which case, that means you cannot yet make a conclusion about the limit of the function. If we have a polynomial function and we are finding the limit of a function as x approaches a is a real number, all we have to do is just evaluate the function when x is equal to a. So that is like direct substitution. Evaluate f of a. Let us find the limit of this function as x approaches negative 1. It is a degree 3 polynomial function. And so what we do is we just evaluate what is f of negative 1. And it's equal to negative 2. But it can happen that when we are evaluating the limit of a polynomial function as x approaches infinity or negative infinity, these are the things that can happen. It can be equal to infinity. It can be equal to negative infinity. If these are the results, then it's just fine. You will just say that the limit of your function is infinity, or the limit of your function as x approaches infinity or negative infinity is negative infinity. However, when you see something like this, the limit of your polynomial function as x approaches infinity or negative infinity is equal to infinity minus infinity, this is an indeterminate form. That is not equal to 0 because these are not real numbers. So what do you do? For example, we have this. The limit of this as x approaches infinity is infinity minus infinity. That is an indeterminate form. So this is what you will do. You will pay attention only to the dominant term. And the dominant term is the leading term of your polynomial function. Why so? Because the dominant term or the leading term is the term that will most significantly affect the behavior and direction of your function as x approaches infinity or negative infinity. Okay, so this is what we shall do. We shall find the limit of polynomial functions as x approaches infinity or negative infinity, and then we will verify the result with the help of the graph. So this is a polynomial function. We are evaluating the limit as x approaches infinity, we will pay attention only to this term. And 5x squared as x approaches infinity approaches infinity. Let us verify that from the graph. So this is the graph of the function y is equal to 5 times x squared minus x minus 3. As x approaches infinity, our function goes to infinity. So this result is verified by our graph. How about this? Let us evaluate, or let us find the limit of negative x cubed plus x squared minus x as x approaches infinity. So what is the dominant term here? The dominant term here is this one, the leading term. And the limit of that as x approaches infinity is negative infinity. So this is the graph of the function y is equal to negative x cubed plus x squared minus x. As x approaches infinity, our function goes to negative infinity. So again, the graph is verifying or is agreeing with what we said. It's the dominant term that will tell you the limit of your function as x approaches infinity or negative infinity. How about this one? So the leading term here is the limit of that as x approaches negative infinity. Look at that. X to the fifth as x approaches negative infinity is negative infinity. Okay? But that is preceded by a minus sign. So this is equal to positive infinity. Let us see what the graph says. When x approaches negative infinity, our function goes to infinity. How about this one? So the leading term here, the dominant term here is x to the fifth power. So the dominant term here is this one. And what is the limit of that as x approaches negative infinity? It's negative infinity. Let us verify that from the graph. As x approaches negative infinity, our function goes to negative infinity. So, when you are evaluating functions, polynomial functions as x approaches infinity or negative infinity, what you do is you pay attention only to the dominant term. And the dominant term is the leading term. And it is the dominant term that will most significantly affect the direction or behavior of your function as x approaches infinity or negative infinity.